In this video, we're going to explain the concept of regularization to a grandma. This is by far one of the most popular interview questions. Convince your grandma that regularization is important for improving a machine learning model. Now, why do we need to go for regularization for a machine learning model? To improve the generalization ability of a machine learning model. What do we mean by that? Look at this cartoon. If you're forcing someone to just connect all the dots, and if you're in fact torturing someone to connect all the dots, you'll end up with some pattern. That pattern might not be one you intended to, but in fact, when you're forcing someone, right, you get answers, you get some answer, but that might not be the answer that you're interested in, right? So that's exactly the concept of overfitting. When you are building machine learning models, and when you are forcing the machine learning model to pay too much attention to the training data set, then the machine learning model might output patterns like this. You see a bat here, that it is possible. And this pattern might work only on the training data set. Whenever the model sees any new data points, it might fail miserably. That's the point of overfitting. We don't need perfect machine learning models. We need machine learning models that are generalizable. That means these machine learning models should be able to perform reasonably well in a variety of scenarios. That's exactly what we need, and that's exactly what regularization helps us achieve. How does regularization overcome overfitting? Let us understand with a simple example to explain the importance of regularization with grandma. Okay, so there are three types of regularization: L1, L2, L1/L2 regularization. We'll first take a simple example to understand L1 and L2, and then we'll come to L1/L2 regularization, elastic net. Take an example of a grandma telling kids to enjoy a fun fair, and she has also laid down two ground rules. Rule number one, ensure the ticket spending is not more than 50 rupees. Rule number two, return home within an hour. And she has also given a choice. Kids can choose to honor either instruction 1 or instruction 2. Let us see what happens when the kids decide to honor only instruction 1. Here, money is more important than time. That's the reason why what kids can do. Kids can just observe all the 10 rides in the fun fair from a distance, figure out which rides are like really interesting, and then take only those rides. Say, for example, out of 10 rides, let us say they find only 4 rides interesting. They will take only those 4 rides because here money is a constraint for them. And if you apply this into the world of machine learning, Lasso regularization cuts off those variables which are unimportant. Say, for example, when it comes to predicting the price of a house, what if whether the house has a garden or not is, let us say, less important? When if you apply Lasso regularization to that machine learning model that is trying to predict the price of a house, it will retain variables like area of the house, number of bedrooms, and it will just eliminate unimportant variables like whether the house has a garden or not. Sure, some people might give more importance to garden, but comparatively, relatively. Right? And how do we achieve this? We just add the magnitude of each coefficient of the variable also into the cost function when you're trying to reduce it. Right? This is Lasso. What about ridge regression, L2 regularization? Right? So here what we do is we are focusing only on instruction 2. And in instruction 2, time is a constraint. Money is not a constraint. So what will the kids do? First 30 minutes, they'll be quickly sifting through all the rides, making sure that they're enjoying all the rides. And then they will shortlist, okay, out of these 10 rides, we enjoyed these 3 rides, right, the most. Now what they will be doing? They'll, for the rest of the 30 minutes, they're going to only spend in going through these 3 rides. Here, they're pretty much taking into account all the variables. They are not eliminating any variables. They're not eliminating any rights. And they are always giving importance to the most important variables. The subtle difference between L1 and L2 is that in the case of L1, you might end up with some variables not even making it to the final machine learning model. The coefficients will be 0. In the case of L2, you will see some value attached to even unimportant variables. The only thing is the most important variables will be having a huge amount of importance. Right? And this is how you achieve it. The cost function, you add the square of the magnitude of coefficients of variables. Now, what is L1 and L2 regularization elastic net? Here we give importance to both the instructions, both money and time, right? And we control the importance with a value alpha, which is a value between 0 to 1. So here, no need to sacrifice one technique for another. We combine these two and then we'll try to figure out which of these three techniques result in the most generalized machine learning model. Hope you guys enjoyed this video. See you soon in another concept that is explained to a grandma.